All right. Hi, everyone. Welcome to the live coding session day 2 for data science class. It's nice to be back here again. Okay. I'll just wait some few minutes for you guys to join before we continue. Okay, I will just wait a few more minutes for some students to join, and then we continue. Okay. So while others are trying to join, okay. All right, welcome. I can see Excel. I can see Vara. I can see Andrew. I can see, I hope I'm not mispronouncing your name, Voin or Yoin. Pardon me if I've mispronounced your name. I can see Press. I can see iPhone. Yeah, I think I saw iPhone in the last class. You're all welcome to today's session. I can see Sefinat. I can see you. All right, welcome everyone. Today is day 2 of the live coding session for HC Data Science. So today, in our last class, we went through the introduction to logistic regression and we familiarized ourselves with the concepts and what it's all about, which is basically how to classify some data, true or false, yes or no. But yeah, the one we treated was us classifying some flowers and towards the during the prediction and the testing of the model we saw that it was perfect, like too perfect, and when we checked the data it was few, which now led us to believe that the model was overfitted with data, so that was why it was too perfect. Yeah, and yeah, we just talked about it, but today we'll deal more on the metrics and we'll be working with a whole different set of data. Then we'll get to understand metrics, evaluation of models, how to better understand them, and how it can help you in your model building. All right, so I'm just going to go ahead and share my screen. And please, if you have any question, feel free to ask. All questions are valid. Feel free to call my attention to that. All right, so I'll just share my screen. It's just some few slides, then we jump into the notebook. Okay, so we'll be looking at measuring classification performance for today. So it's going to be more of how to measure the performance of your model after it's done predicting. Okay, so that's what we're going to be treating today. Let me move on to the next slide. So model evaluation, and model evaluation is actually very important. So it's just basically about answering the usual question, how well does your model perform? One thing is you building a model, another thing is you able to, measure how good it's performing so that you'll not end up building a model that is performing worst or is not giving you the right results. So when we talk about model performance, we are looking at two distinct arenas. The model ability to learn from the training data and its ability to generalize this learning to an unseen data. It's one of the process we usually take. We split data, the training and the test. we train it using the training data, and then we use it on the test data. So the ability for it to learn from the training data and then predict the test data is just what we want to focus on today. So beyond validation, model evaluation is also about improvement. So by identifying where a model falls short, evaluation metrics provide us with signposts for refinement. So whether it's tuning hyperparameters, selecting features, or exploring different models architecture, right? So there are scenarios where after predicting, if you go to the advanced part, you see where you create a pipeline and several models. Then after the first running, you select the one that is performing better. Then go into um, tuning the hyperparameter it has for more better performance, right? So exploring all these different model architecture, the insights gained from the model evaluation inform our path to enhancing the model. So we have the classification matrix. Um, yeah. So under it, you can find accuracy, precision, and recall. We saw some of this in our last class. So like I said, today we are just going to emphasize more on it. So accuracy, right? It tells us the proportion of total predictions of our model got right. It's like what it predicted right to what it was supposed to be. So sometimes it can be misleading, especially in scenarios where the classes are imbalanced. Yeah, you could have a high accuracy, but most times, yeah, like you said, it's misleading. So you could have imbalanced data. This is when maybe they are trying to classify yes and no, and the population of yes, or let's say the count of yes is far more higher than that of no. The data is imbalanced. But yeah, accuracy is one of the metrics you can use to evaluate some model. We have the precision and recall. This measures the accuracy of positive predictions out of all the instances the model labeled as positive. How many were actually positive? While recall, on the other hand, assesses how well the model can identify actual positives. So it's about capturing as many true positive as it can. Then we have the F1 score. This is recognizing the tension between precision and recall. So F1 score emerge as a balanced metric. You go online, they'll say it's harmonic mean, precision, and recall, providing a single measure to assess a model when we seek a balance between identifying relevance instance and maintaining accuracy in predictions. So all these measures I've mentioned, they're actually very important. It's actually what would assist you or give you age on how well your model is performing. So let's do more on accuracy. I already talked about it, or I defined it. It's defined as a correct predictions, as a true positive and true negative made by the model out of all predictions. So it's a straightforward measure that tells us at a glance how our model is right. And the formula is the number of correct predictions over the total numbers of predictions. Then when should we use this accuracy? It's mostly used when the classes in the data set are relatively balanced. What do I mean by that? If you are trying to classify maybe out of one and zeros, you can use it when you are very certain that both of them are balanced. In a sense, let's say your entire observation, that's rows, is 100. Then you are certain that 50 of it, that's 50% of your data is 1, 50% is 0. Then your accuracy can be used in that scenario because the data is balanced. But there are some limitations, imbalanced classes like I talk about, the misleading interpretation, right? So those are one of the things that can um, that you need to check out when you are trying to use accuracy as your performance metric. All right, so while accuracy remains a valuable metric for certain applications, its effectiveness is contingent on the context of the problem. Recognizing its limitation helps us avoid over-reliance on a single metric and encourages a more comprehensive approach to evaluating our model. Please, if you have any question, you can always, I think I say message in the chat. Okay. Hello. Can you guys hear me? Just to be sure.
Yes,
Someone
we
can just
can.
unmute his. Okay. Okay. Thank you. All right. The next one we have is yeah, is the precision and recall. So precision, it measures the accuracy of the positive predictions made by the model. So this is how many was predicted correctly, positive. It answers the question of all the instances labeled as positive, how many are actually positive? That's what precision answers. Of all the instances labeled as positive, how many are actually positive? That's precision, right? So precision is particularly important in situations where the cost of of false positive is high. It has its own formula that's true positive divided by the sum of true positive and false positive. So when you combine true positive and false positive, you have like all the positive, right? Both the one that was classified as true and the one that was false. Then out of the two, the one that was true divided by that sum is actually precision. Then we have recall, also known as sensitivity or the true positive rate. It measures the model ability to identify all relevant instances within a dataset. It addresses the question of all actual positive, how many were correctly identified by the model. So in our test data, we have one. Let's say we have inside our test data we have let's say we're trying to classify 1 and 0. You have 1 in 50 places. So recall is like out of that 50 that was a value of 1, how many was the model able to identify as 1? That's recall for you. Of all the actual positive, how many were correctly identified by the model? So recall is crucial in context where missing a positive instance has serious implications, and that will mostly be in the medical industry. You wouldn't want to, maybe someone is having cancer and you're classifying the person as false. So when can you prioritize precision or recall? So the importance of precision versus recall varies by application. In the medical diagnostics, for example, high recall might be prioritized to ensure all potential cases of a disease are identified. So yeah, when you're dealing with, say, with medical data, you just need to make sure that your recall is very high because this is like medical industry, right? Like I said, you wouldn't want if someone is having that disease and you're classifying the person as negative. So your recall, the ability for the model to identify the positive um part of the to identify something as positive is very, very important. Then conversely, in email spam detection, high precision is preferred to minimize the risks of marking legitimate emails as spam. So yeah, that scenario is like email address or emails, sending out emails. So you want to soon make sure your precision is high in that aspect so that you not end up flagging a legitimate email as spam. So that's just how you can or when to prioritize precision and recall. We have the F1 score. F1 score is defined as the harmonic mean of precision and recall, offering a balanced metric that considers both the accuracy of positive predictions and the model's ability to capture all relevant instances. So why F1 score? So in scenarios where both false positive, it's not possible to classify as positive, and false negative carries significant consequence, or when there is an interest in balancing the importance of precision and recall, the F1 score emerges as a critical evaluation metric. So this is like maybe the medical industry I talked about was like focusing on recall using the, the score. Then the spam I talked about it was you focusing on precision. So this F1 is like an industry that relies on both of them. So this is actually the metrics they will actually be monitoring rather than looking at those individual ones. So they'll be like, once the F1 score is high, yeah, it's better. We are having better recall and better precision. So that's just what F1 score is all about. So we went to use it at, for example, in fraud detection system, where both the identification of fraudulent transactions, that's recall. I'll take it again. For example, in a fraud detection system, this could be related to banking, the finance industry, right? Where both the identification of fraudulent transaction, for you to be able to identify them, that's recall to know, that's recall, and the accuracy of these identifications, how accurate are they, are equally important. So the F1 score provides a more holistic view of model performance than either metric alone. So yeah, this is just an example of an industry that needs both recall and precision. So they'll be looking at the F1 score to know how good a model is performing. All right, we have the confusion matrix. We are almost done with our slides. 3 more to go. We have the confusion matrix. We're all familiar with this. So the confusion matrix is a table used to describe the performance of a classification model on a set of test data for which the true values are known. Right, we saw the confusion matrix in our last class, and I think someone was actually, I wouldn't say surprised, but wasn't aware that we had confusion matrices that are just beyond the 4 box. And that is actually when you have multi-classification, when you are not classifying just true and false or one and two. Maybe you are trying to classify high, low, medium, classes that are just beyond two, right? So it allows us to directly observe the instances of correct and incorrect prediction made by the model. So we have the true positive, that is those that were correctly predicted as positive, true negative, instances correctly predicted as negative, false positive, instances incorrectly predicted as positive, otherwise called type 1 error. Then false negative, these are the instances that were incorrectly predicted as negative, type 2 error. So this layout helps us not only quantify the accuracy of predictions, but also understand the types of errors our model is making. I'm still going to see all of this practically. Then we have the ROC curve, that is the receiver operating characteristics and area under the curve. That's AUC. So ROC curve is a graphical representation that plots the true positive rates, otherwise called the recall, against the false positive rate, also known as that should be specificity, and the other one is sensitivity. Yeah. So by moving the threshold for classifying positive instances, ROC curve illustrates how the balance between detecting true positive and avoiding false positive shifts. So the higher that curve is closer to the edge, the better that model is performing, right? So this is also another way to measure the performance of your model. Okay. So say for example, in fraud detection, a lower threshold that is accepting more false positive might be preferable to ensure that no fraudulent transactions go undetected. So this is just another way you can measure the performance of your model. Then we have cross-validation. Cross-validation, I think you mostly find this when you are doing your parameter tuning. So it's just a resampling procedure used to evaluate machine learning models on a limited data sample. The goal is to partition the data into subsets, train the model on some of these subsets, which is the training set, and test it on the remaining set. So it's like if you have, let's say you have a data set of 50 rows, what cross-validation does, it splits it, let's say 40, 10, train it on that first set of 40. Let's say we have A to E. Just picture this, you have 50 rows of data, and you're splitted 10, 10, 10, 10, that's A to E. What cross-validation literally does, theoretically, is it takes A to D, throwing it on the model, use it to predict E. Once it's done, it keeps it. Then it takes B to E. This time around, A is excluded. Throws the data on B to E. Use it like it just keeps training it on subset till it's done in that life cycle, and everything has been done. Then from there, it will now then assess, and the one that was performing better, it will now then bring out the score. It also has something to do with the K-fold. Yeah. So why does it matter? Bias reduction, variance reduction, generalizability, and yeah, I think that's basically it. Then lastly is just conclusion of all what I have said. So metrics matters, as we have said, it is actually very, very important because if we don't know how to measure this performance, you may end up building a model that is not doing the right thing. You may end up building a model that is probably just biased, maybe ends up giving you a positive response when it is negative. So you just need to know how to interpret all those performance so that you know how to tune it to get a better result. So through the confusion matrix, the curve, we've seen also how to visualize and quantify our models. Then the accuracy, precision, recall, F1 score based on the specific objective and constraints of our project. Each of these metrics offer unique insight into our model performance, highlighting area of strengths and opportunities for improvement. We also saw the cross validation. So this is it as a cornerstone technique for estimating how well our model generalizes and unseen data. All right, so we're going to jump into the next the notebook. Does anyone have any question for me before we go into the notebook? All right, okay. But can you guys still confirm that you can hear me?
Yes.
All right, so
Yes,
here
we
is the
can.
practical. All right, cool. So we just want to go through the practical process and just see how this stuff works. So let me connect my instance. So it will be from, I'm working with the social network ads. So it's just a very simple data, right? We have the user ID, the gender, the age, the salary, and if the person purchased something or not. So this is what we are trying to predict. If the person purchased, the person not purchased. Okay, let me just connect to my drive. All right, so I'm almost there. Okay, so these are just the required library for now. We're still going to import more. I'm going to run this. So this is where I read in the data. This is just a small EDA. So this is just a preview of the data. We have the user ID, the gender, the age, the salary. Again, this is if the person purchased something or not, right? Let's look at okay, we have it here. So we have 400 entries, that's 400 observations.
Hello.
All right, so
Please,
yeah, I
can
can
you
hear
zoom
you.
in? See?
Okay, sorry,
Thank you.
hold on. Is it better now?
A little bit more.
Okay, is it better now?
Yeah, thank you.
All right, cool. So yeah, this is just a preview of the data. These are the information. We have 400 entries, that's 400 observations. And looking at this, we know that there are missing values. So the data is literally cleaned. The data types are also okay, right? So that, in other words, it means we're not going to do too much cleaning here. So we don't have any missing value, and yeah, data type looks okay. Gender is text, integer, integer, integer. So the size of data is very small. Yeah, this is just a brief info. This is a brief statistics of the data. So we all know what counts is. It's literally counting the numbers of rows. This is the mean, average for each of these columns, standard deviation, how far the data point is from the mean. We have the minimum value, the 25th percentile, 50th percentile, the 75th percentile, the maximum value. So this is just a brief statistics into the data set. And most people usually detect outliers from here, right? So if your minimum value is 18 and 75% is 46, and it's telling you that the maximum value is, let's say, 1000, you know that there is an outlier because it's just out of the usual range. And just in case you are not familiar with what outlier is, it's basically you having some range of numbers that on enough, say you have a store, say you have a store, and let's say you are making a sales of 20, let's do dollars, $20, $40, $15, $30, $5, right, $8. Then all of a sudden you make sales of $2,000. So this is an outlier. Automatically becomes an outlier because it's just outside the usual range. That's how we usually treat it. But as it stands now, if we were to look at the average of this column, which is the mean, right? If you were to look at the mean, so you would put something like you see that the mean, like the average of these cells, is actually 302. So it's saying on an average, you're making a cell of 302, which you agree with me that it's not really correct. Because when you say an average of 302, so it means that on a frequent basis, you're making this amount of cells. But the moment you take out this outlier, right, the moment you just eliminate it, you will see that the value is going to change. So this make more sense compared to this. So because of this outlier, it shifts the mean to a whole 302. But when you took out the outlier, your mean reduced to this amount, which is, you agree with me, it's just within the usual range you're always selling. So this is just how outlier can affect your data. And yeah, most times you just have to treat it. So we are going to see if our data has outliers. Then already we saw from the data.df.info that there is no missing value. So here also we are confirming that. Then I use Plotly for my visualization. Personally, that's just what I like to use for my visuals. So what I have below here is just me plotting the distribution of the numerical fields we have. So we had age of the people. We can see the mark, the minimum value, the lower fence, first quartile, the median, and the third quartile. You can also validate this from the EF.describe that we did. Just in case you're always confused. What we are saying in this box plots, let's look at age of people. What these values you're saying is actually what you're also saying here. 75 percentile was 46. So if you also come here, 75 percentile is actually here, this line, and you can see that it's 46. So that's just how you can also interpret it. And mostly we use box plots for, we mostly use it to detect outliers, right? But then again, the interpretation is this is the minimum value, this is the first quartile, this is the median, otherwise known as the 50th percentile, this is the third, and this is the upper fence. Now, had it been there was outlier, like in this case now, let me see if I can plot this quickly. Going down with search. Just give me a sec. Sorry. It's too small. It's our data is limited. Like we don't have. Oh, sorry. Let me allow some people in. People are waiting to relate in. Okay. So I just try to visualize this using a box plot. Now, um, forget the fact that the data is not that much. Or let me do something like this. So hold on, give me a sec. So you have I just added more picture. Then what will actually increase it is to okay, sorry, did not work. Okay, I think I just need to add a value like 1000 for the box to come off. All right. Wait, I'm not trying to see if I can bring up the box, but that would mean putting a lot of data. But yeah, we don't have that luxury of time. Now, my point is, you can see very well that 1000 and 2000 are outside the usual box range. So it's just how outliers are being detected with box plots. So it's always going to lie outside the usual range. And right now it's saying that the maximum value is actually 100. So it's saying from here to here as the usual range. Then, sorry, here to included. But now these two are seen as outlier. So that's why it's presented like this. But yeah, luckily for us, our data does not have any outlier. If not, we will actually detect those small dots above it. This is a histogram showing the distribution of the ages of people. So the cluster is more, we have more people that are between 36 to 57 years. Sorry, 34 to 35. I think there are 38 if 38 in count if you were to count them. Yeah, that's what it means. But yeah, the range is between 34 to 41. That's where we really have more frequency of that's where the frequency lies most. Estimated salary, yeah, again the box plot. We have no outliers. Then we have the estimated salary. People earn within this range more. 52 of them. Okay, but then this is just a very minor EDA. Yeah, I wanted to do something different today. So we have a little idea about the data just to have an insight into it. We still have another one here. This one is showing us the estimated salary by gender. So this is the salary by male category. This is the salary by the female category. So what can we bring out from here? Again, we can say that the female categories, they are third quarter people that are earning up to people on the up to on this third quarter are actually large compared to this. Then I don't think the median is almost the same. The median of female is higher than that of male. Yeah, but then again, this is what it shows for the male and the female category. But I think we have more females than male based on this distribution. Um, let me just validate that. Sorry. Yeah, wait a second. Oh, okay. Just give me a sec. Data is correct.
You can use value counts. You call the value counts method on the gender.
Yeah, okay. So yeah, that's much. Female is actually higher than this. This should be, sorry, tomato. Okay. All right. So we have more female than the male category. We have more female than the male category. So that's why we actually this distribution is actually longer than this one. Okay. Um, what do we have here next? We have distribution of number of people that purchase. So this is actually the target we want to predict. Yeah, we can see obviously that the data is imbalanced. This was what I was talking about. We have 257 observations that are zero, people that did not purchase, and we have 143. So when you are doing this kind of I mean, we're going to see the results very soon. But yeah, the data is imbalanced. They are not equal. Then the time is running, so let's be quick a bit. Number of people that purchased by gender. So under that, I think we are just dividing this into the gender category. So have more. Sorry, where is this picture? Yeah, we have the more female here and we have more male on this side. So this is the correlation and this is our area of focus. So from here we can see that the correlation between purchase and other features in the data set. Um, age has a higher correlation followed by estimated salary. So these are like two features that will probably help us in predicting the purchase more compared to the user ID. And obviously user ID doesn't really make any sense because I don't think it has any effect on if the person would buy the data or not, but age and estimated salary could be a factor. So we can see that the correlation is actually high. I think it is just me plotting it in a chart. Yeah, that's just a chart. Time is already running. Yeah, this is where we start the whole model processes. So here we dropped the user ID. Then we did a one hot encoding. This is because model logistic regression does not take in um values like text. So we are just renaming it. The male is zero and the female is one. So wherever we see zero and one in the gender, we know that it represents male and female respectively. This is just another way to do it using words and one hot encoding that is getting dummies. So this one is just going to split the data into two, but yeah, I just highlighted that. Okay, after we've dropped the target value, we assign the remaining features to our X. Then our target has been assigned to the y variable. Then we have to normalize the data. You have to put everything into a normalized form so that you will not maybe one column is having a different set of range, another one is having a different set of range. I think I read the benefits here. It improves the algorithm performance. Then it also has a fairness on feature representation. This ensures that each feature contributes equally to the distance computation. So yeah, I did a standard scalar here to normalize the data, and this is what it looked like. Then this is where we split it. This is 80-20. Yeah, and we fit it in, and we did the prediction. We already know what the regression is. The parameter C you're seeing here is just like tuning the model. So it just helps in making sure that we are applying a fairly strong regularization to the model. This can help generalize better by keeping the model coefficient smaller and simple. We all know what this max iteration do is just a way of helping the model iterate several times before it converges. So that it should be more it will train better, right? So the larger it is, the better the model trains better on the data before it is a point of convergence. I'm actually rushing because of time. All right, so the weight coefficient and bias. So this is just the numbers that is being multiplied to each of the features in the model, and this one is actually the bias of the model. Here's where I explain them. Someone is trying to tell me. Okay, yeah. So each coefficient corresponds to the feature in your input data. That's the remaining three columns. So this is multiplied by the first feature, this by the second feature. And how does it impact the model? The larger the absolute value of the coefficient means that the corresponding feature is more important for predicting the output. So if we notice to this one this should be for the age, which we saw earlier on through the correlation, that it was actually high when we checked it with the target variable. So that's why the coefficient is also high. And for the bias part, why are we bringing it, checking it? This allows the model to adjust the output independently of the input feature, providing an additional degree of freedom. This helps the data fit the data, so it shifts the decision boundary of the model. Negative bias, as in our case now, means the model tends to predict lower value before considering the effect of the features. Okay, so this is where we start looking at. We've done the prediction just in case you missed it. We did the prediction here. After splitting, we trained the model. This was where we did the prediction. Okay. Okay. So this is where we actually check the accuracy. So when we check the test accuracy of the model, how the model is performing, it's saying a performance of 0.86, while on the training data set, it's giving us performance of 81%. So this is how accurate the model was able to identify the correct labels in the training data set. Then this is how accurate it's able to detect it on the test data set. So this is just an explanation. Probably have to send the notebook across, but it's just write-ups of the results we have here. So yeah, 81.25% means that the model makes prediction using the data and it gets 81.25% of those predictions right. This indicates how well the model has performed or has learned from the data set it was trained on. Then we have the test accuracy too. So it's also how well the model has performed on as unseen data, right? So the fact that the test accuracy is higher than the training accuracy is somewhat unusual, but could be a good sign indicating that the model is not overfitting to the training data set. Then we have the classification reports we talked about, the precision, the recall, the F1, and the support. So this is what the value looks like. For the precision, remember it's how accurate it's able to detect the true positive. So 85% was very accurate. This is how it's able to recall. Then F1 score is more like balancing the two. But if you check for this one, the recall is not that high, not that high. So you may want to do some parameter tuning to adjust it so that it can be able to recall or have a data recall score for those that are classified as one. That's those that bought or purchased something. Then this is the accuracy restore. So I'll just go through this right up. So for class 0, the precision is 0.85, meaning that when the model predicts class 0, it is correct 85% of the time. That's what this precision is saying. Then for recall, also known as sensitivity, for that class 0, this is 0.96. What is it saying? It successfully identified 96% of all actuals class 0 instance. So it was able to detect 96% of them correctly. That's for class 0. It was able to detect 96% of it. While we saw that for class 1, it only detected 68% of it correctly. So you want to tune or adjust it so that you I think in this part now you can't use this model in a medical industry because the recall is very low for those that are positive, those that purchase or those that probably has cancer. The recall is very low. So yes, you would want to tune that data. The F1 score for class 0, the F1 score is 0.90, indicating a good balance between precision and recall. So this one is comparing both. So the score is actually high and it's good. So this is the type we can use to, when we talked about that loan industry, this is the score we can, okay, say, yeah, we can use this model for our loan. We have the support. This is just showing us the distribution of our test data. So they're actually 80 numbers. So 52 of them is 0. Those that did not purchase. 28 of them is 1. And already we know that it's imbalanced. So that could be the reason why this recall is also low. It could also contribute. So we need to balance it. It's something that you can probably do after the class. See how you can balance it using the smooth way, or you can manually just do that by filtering the data. Accuracy, we talked about that already. 0.86, which means it correctly predicts the class 86% of the time. Correctly predicts the class 86% of the time across both classes. Micro average, the average precision recall and difference score between the classes. The weighted average, the weighted average F1 score is 0.86, which adjusts for the number of samples in each classes. So yeah, that's basically it for what we got from here. So before we close, let me see the other one I wrote here. This one is the confusion metric, showing us the actual positive and the actual negative, and those that were predicted falsely. So 50 were predicted correctly, 2 was false, 9 was predicted correctly. So this is where that recall is low. You can see that out of the 28, 9 of them was correctly identified, while 19 was not. So we just need to be able to tune your model so that you can have a better score, a better prediction for this. So that's the confusion matrix we just saw. This is just an explanation. The two positives, which is 50, this one, two positive, false positive, two negative, false negative, false negative. So it's always confusing. Okay, so this is two positive. False negative is the one we have value 2. This is the false negative. This is the true negative and the false positive. Okay, okay. True positive, false positive, 2 negative, false negative. Sorry, I think I will just have 2 positive 50. Got the 19 and the false negative. Got it. Okay, so yeah, this is the interpretation to it. So the false negative is just 2, the false positive is 9 of them. But yes, this also would also help you in knowing if your model is doing well or it's not. All right, I think I'll just stop there. Does anyone have any question for me? So basically, these are
Um,
just
Yeah,
different ways you
hello.
can measure your. Yeah, any question? Let me check the chat box.
I would just like to know how we can have access to the notebook. If you can share a link to the drive.
Uh, yeah, I'll do that. I think I can do that now. Uh-huh.
Thank you.
Yeah, someone hand is off.
Yeah, so I wanted to ask. So there are so many questions I wanted to ask. Okay, but for let me start from the ROC call. Can you hear me?
Okay, yeah, I can hear
Yeah,
you.
the ROC call. So what do we plot on the ROC call to confirm to help in that's I'll ask them at once so that you can answer them one after the other. What do we plot on the ROC call to confirm or to evaluate a model? That's number one. Number two, um, if after creating a model and also after and um, doing the prediction and we get a low score, so what do we do? Do we dump that model and go for another one, or what do we do now to now improve the model? I've forgotten the third one, so but when I remember it, I'll ask. So you can answer this too for me.
Okay, for the recall, we actually have a plot for it. I didn't want it to go there because of time. So what we plot here is actually your test data with the prediction, right? You're looking at what you predicted, you're comparing it to the ones you predicted. So how it works is when you say ROC, this is just the curve we're talking about. Don't mind that it doesn't look like a curve, but yeah, it's just closer to this edge. And the higher the curve is far away from this diagonal, the better your model is. The better your model is. So it's just the true positive rate and the false positive rate. So if it is coming down, that means you're not predicting, or the model, sorry, not you're not, the model is actually not performing very well, right? Then the other one about what was the second question you asked? Okay, if you use a model and it's not giving you a high score, uh, most times that's why we always test different models. There are some points you use different models, you put it in a pipeline and you just train and fit them in and just test all of them like at first. Then when you check the score for they'll always be different. One must probably be doing better than the other one for that very first time, maybe without any tuning and anything. So once you're able to detect that, you now then work with that model. Or aside that, let's say you're just focusing on one model, like in our case, what you can do is I somewhat believe that inside these logistic regressions, there are other parameters that you can use to tune. So you don't need to do what is
Okay,
hyperparameter.
that's where parameter tuning comes in.
Exactly. Yes. That's where parameter tuning comes in. I'm trying to so let me try something like this. Okay, I didn't think I run it, so yes, but that's where parameter tuning comes in. That's parameter tuning comes in. I'm going to have an error. Please hold on. Let me just run this code. Time is after. Time is not on our side. I'm going to click play. Okay. I'll let this thing. It's something I wanted to bring out the picture because it's kind of is what I'm looking for. Yeah. So we have different parameters inside the stuff that you can choose. You can tune. So what you can probably do is to go and look at the documentation of that model to know what you can tune to probably adjust it. And also depending on what your result looks like, you now then know what to tune. Then also inside this logistic regression, we also have different different algorithm. By default, it's this LBFG. It's just one of the different solver that you can change. So you can also change it to something else. But yes, you're going to do hyperparameter tuning to increase the score of your model. Any more question? We have 2 more minutes.
Yes, I have a question, please.
Okay.
All right. Concerning the target output, in your own example here, what we have is numerical value 0 and 1, isn't it? Now, how about where you have categorical output, even though it's a classification, but it's in text? And how are you going to do the AUC, and the rock? How are you going to plot it? How are you going to do that?
I don't think I follow. You're saying if the what we want to classify are text, not numbers. Is that what you're saying?
Yes, because here you have numbers there, so it was easy for you to plot the graph. It was easy for you to do the what's it called now? The area of, if you can go down, the AUC and the rock,
Yeah.
ROC
Just
plot. Where
just
you
so you
have,
know. Okay,
in
go
a
on.
situation
I
where
can
you
hear you.
have, in a situation where you have categorical output for your target, not numerical output, how are you going to, address this particular AUC area under the curve? How can you plot it? How can you do it?
Okay.
It was easy
I
for you to
understand.
plot it because
I understand your question. Then first thing I'll say is most I think what you always get from a model as a response, that's the prediction, is always going to be numbered, right? And right now I'm not aware if there is a model that can predict like yes as the answer. It's always going to be in a numerical form. Then it's probably when the result comes out that you can change it to a categorical form. So and another thing too, it's what is coming out from the model that you'll be using to predict. So if maybe you're working with a model, I'm just saying, and your model is predicting yes, like in terms of text, what you can do is just use one hot encoding, like change the yes to one, change the no to two, turn it into numbers because you know very well that you can't plot text in charts. It has to be numbers. So what you can do is if indeed there is a model that maybe is giving you yes and no as a response, just change it to numbers. Yes to be one, no to be two. Convert it, use it on your plot, pass it probably as the y label or the x axis, and you have your result. But then again, I'm not sure model like predicts. Yes, it's usually numbers. You must have encoded. But I know that model can take in like there are models that can take in categorical values. Yeah, I'm aware of that one. But for the response, I'm not sure. I wouldn't say it's not possible, but
for those ones
I
that is
don't think
called multi-class, for multi-class, yes, you can have the text as the output for multi-class. Yes, you can.
Okay, if you say so. I mean, I won't argue. This is we are in the generation that anything is possible. But then again, for chat, we know that we can't plot text on chat, so we always have to convert it to numbers. All right, guys. We have
Right, I
already
think I get
elapsed.
you.
So
Please, the
you
So
notebook.
understand, right?
please, can you share the notebook, please?
All right. So yeah, let me just do that if I leave the call. All right. So I'm going to show it on the in-chat message. So you just pick it from there. You need to. I'll give you guys like 3 minutes to pick it up before I end the meeting. Okay, I think I don't know how I'm going to do. Is there like a group chat for you guys? I can just drop it there. I don't think I can share this link.
Actually, you can't drop it on the group chat, Goodrich. It's
Okay,
only
okay, okay.
available
Group
for
chat
those
there.
who attended the live coding session.
Okay, okay. I think that's fine that way. I'll send the notebook across on the group chat. All right. Thanks, guys. I'll see you guys in our next class.
Sorry, I've not.
Right.
We have. I don't know. Have you dropped it already? Because I can't see it.
No.
I've not dropped it yet. I'll pass it to someone that is in your group chat. I don't think I am on that group
No,
chat.
but she just said that you can't drop it on the group chat. That it's for people that are online
Oh,
currently.
oh, okay. Sorry, no, just give me a second. I think I misunderstood her. Okay, just give me a sec. Just give me a sec. Just give me a sec. Anyone with the link? All right. I'm going to show it now on the income message. So just pick it from there. All right, I'll share it. All right, so I'll just give you guys like 2 minutes to just try to click on it, then I'll end the meeting. So 6:06, I'm ending the meeting. Please confirm that it's accessible just in case you're with your laptop.
Yes, it is, but it's showing something like a Word format. I don't know if that is
Like
why.
lot of codes.
Ah?
I'm experiencing the same thing. Like it's just a lot of codes.
Yes, a lot of codes.
Oh, okay. I may
Just
know
hope
why.
it's
It's not a
a
Google
Python
Colab
app.
notebook. Please, you need. Okay. What we are saying, please, click on download. Click on download. You need to download the notebook. It's not a
So
Google
if you
Colab that
download
it's
it, you can
easily.
open it with
Yes,
Google.
download it, please. I think I know what you're saying. Just download it. You should see a download button.
Okay, yes. It's
Yes,
it's
thank
a
you.
Python file. Thank
All
you.
right. All right. All right. Bye,
Thank you.
everyone.
All
Bye.
right, sir. Bye.